So now we'll see that what will happen if a vehicle is moving in a banked road. Okay, see, look at the figure. Look at the figure. So you have an angle theta. Okay, the vehicle is, it's like this, correct? So it's more like bent, you can say. So here, see, again three forces are acting on the body. One, the normal, one the weight, then one more the frictional force, correct? The centripetal force basically, like what we did for the level road, same thing. See, but here one very important thing is we have to resolve the vectors here, correct? Now, if you look at the figure, see n cos theta, right, n sin theta, f cos theta, f sin theta, correct? So we have different types of forces acting on it. Okay, now see here, the normal, see look at this is n cos theta, which is going up. Now the weight and the f sin theta component, they are acting in the same direction. So we can have n cos theta is equal to mg plus f sin theta. Correct? So call this as first equation. Now see, the second equation, the horizontal component will add everything. You have f cos theta plus n sin theta is equal to mv square by r, because that's the centripetal force, right? Correct? Now, so then what did we do? So we have f less than or equal to mu into n. Correct? So that's the whole point of it. Now let's say it is equal to mu into n. Alright, so then what we have, see, basically we'll get this as n cos theta is equal to mg plus mu n sin theta. Basically for the first equation, instead of f, we put it as mu into n. So mu n sin theta. Now take that mu n sin theta to LHS. You get n into cos theta minus mu sin theta is equal to mg. Right. Now the next one is mu n cos theta plus n sin theta is equal to mv square by r. Here also, in place of f, we are substituting mu n. Okay. So what you will get is n into mu cos theta plus sin theta is equal to mv square by r. Right. Now what we do is we divide these two. Okay. So once you divide, see, basically I am trying to divide the first equation, that is mv square by r, and then mg. So these two equations we are trying to divide. So we'll get this as mu cos theta plus sin theta divided by cos theta minus mu sin theta is equal to v square by rg. You guys understood how we got this? Right, so I'm trying to divide, right? So that's the reason we got this. Alright, see, next what we do, we multiply rg. That is, v square is equal to rg into mu cos theta plus sin theta by cos theta minus mu sin theta. Understood? So then what we do, we divide the numerator and denominator by cos theta. Okay? See, mu cos theta by cos theta cancels. Sin theta by cos theta is tan theta. Right? So now v square will reduce to v square is equal to rg into mu plus tan theta by 1 minus mu tan theta. Okay, so 1 minus mu tan theta. So basically this particular mu what we are taking, if we consider the mu s value, the static friction, the coefficient of the friction, then V max is equal to root of rg into mu s plus tan theta by 1 minus mu s tan theta. Okay, so this is what you get. Now if you look at this, see here the banking of the road, that clearly cuts down the speed. Correct? So, or in other words, what I can say is it actually clearly cuts down the friction. So whenever you're banking of the road, you can travel in a faster way. Like instead of saying 100 km per hour, I can go up to 150 km per hour. That's why banking of roads is very, very important. And whenever, if you have noticed, if you see any hairpin curves, during the ghats and all these things, if you see that the road will be curved here and there will be a bend in the road. That's nothing but banking of the roads. Okay, banking of the roads, that helps you in actually, so that you can maintain speed, and it helps you to cut down the friction. Understood, right? So this is the formula for maximum velocity whenever the vehicle is moving in a banked road. Understand? So go through the video again so that you understand it better, and then we'll start solving problems from the next exercise. Thank you.